So we're moving on to muscle contractions, and before we learn the different muscles in your body and what their names are, we first have to think about how is it that a muscle is able to contract and relax. So first thing we're going to talk about is contractility. This is the muscle fiber's ability to undergo shortening and become thicker. Now, that is what happens in a muscle contraction. So if you look at, I always use the biceps because it's right here on your arm, but when your arm is relaxed, you can, I can't pull my shirt up enough to see that, but when your arm is relaxed, that muscle, you can kind of move it around a little bit. It's not hard, it's fairly soft. But when you make a muscle, if I was really muscular, if you get your boyfriend or your husband to do this, when you make a muscle, it gets shorter and bigger and it gets thicker. That's because the muscle is now contracted. So there's always a shortening of the muscle, which makes it thicker. That's what contractility is. Second bullet point is skeletal muscle contains two different kinds of proteins. They're called actin, A-C-T-I-N, and myosin, M-Y-O-S-I-N. Actin is thin and light, while myosin is dark and thick. And the 5th bullet point on your sheet, it says these filaments are present in alternating bundles in a muscle cell. This is your striations, and you all saw these striations under a microscope. Remember what two types of muscle have striations? Cardiac and skeletal, those are the two. Smooth muscle is not striated. So when you see striated muscles, when you see the tissue is striated, which should remind you of striped, you have thin actin and thick myosin filaments, and that's what gives you that alternating look. The last bullet point is a sarcomere. A sarcomere is one contractile unit in a muscle. Just like in compact bone, we said an osteon is one unit of compact bone. A sarcomere is one contracting unit in a muscle. And it is going to consist of bands of actin and myosin. And right here, you have a picture of what a sarcomere looks like. Now, in your margin, I would like you to write the word sarcolemma. Okay, sarcolemma. So S-A-R-C-O-L-E-M-M-A, sarcolemma. This is actually the membrane that goes around a muscle fiber, like the membrane around a cell. Okay, which anyway, for a muscle, it's called the sarcolemma. Now, sarco is always going to, S-A-R-C-O, that is always going to be referring to muscle, just as myo or mesium is going to be referring to muscle. There's a couple of different word parts that when you see them, you can kind of guess that we're talking about muscle. So the sarcomere is a contracting subunit of skeletal muscle consisting of bands of myosin and actin fibers. Now, kind of look at this page, have that picture in front of you while you look at the next page, which is going to tell you the different parts of that picture. I'm going to go through these rather quickly because it's just going to be a matter of you taking the time to learn these different parts. But the A band is the entire length of the thick filament, the entire length of myosin. The I band is where the thin filament, actin, is all by itself. The H zone is where the thick filament is all by itself, myosin. There's no thin filament, there's no actin there at all. The M line is the center of the A band and is the attachment for myosin. And the Z line or Z disc, depends on what book you're using, the Z disc is in the center of each I band, which is the thin filament. It's the center of each I band, and it anchors the thin filament. From one Z disc to the next is one sarcomere. Out of all this stuff, please star the Z line. That if I had to have you remember anything specifically, it would be knowing that the Z line is from one Z line or one Z disc to the next. That gives you one sarcomere. And the fact that one sarcomere is one contractile unit in skeletal muscle. That's the important thing to take away from this. Now, the next page is this. I actually don't want you to look at this right now. Actually, what I would like you to do, if you haven't done it, stop this video and go print this, which is listed in your Blackboard notes as a separate little thing, a separate file. The sliding filament theory step by step. Now this is one of those situations in anatomy where I wish I could teach you one thing first and then come back and kind of go back and forth, but you can't. So we're going to talk about a couple of things in this step-by-step sliding filament theory that we haven't talked about yet. So it's going to be a little hard to understand, but as we get through the rest of the unit or the next few days, it will start making sense. And I am going to go through this with you the next time I see you in person, and we'll go through it together again. But I would like you to have both of these sheets of paper in front of you, and then you can go back to this, which is just another summary, and you can look at it, and it's kind of a different way of looking at it. Someone else explained it. You can look at that. Now also, please, 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 I have posted, I think, 3 or 4 videos explaining this sliding filament theory. Now let me tell you right now, the sliding filament theory is how muscles contract. See, there's sliding. The actin and myosin, the thick and thin filaments, are going to slide on each other, but it's a little bit more complicated than that, so you have to watch these videos to see, and I want you to watch them a few times because then it will get in your brain. Do not memorize this stuff. Just like every other chapter in anatomy, don't memorize it. You really have to understand it. If you don't understand it, you call me. You tell me to come over to your table and we'll go through it again until you truly just understand it. Memorizing never helped anybody with anything, okay? It's just not any good. So let's go through this sliding filament theory. Have a pencil. I want you to make some notes in the margins. There might be a couple things I might say that I want you to remember, okay? The first one here, it says the nerve impulse sent to the muscle from the brain in order to tell the muscle to contract. Okay, so we said skeletal muscle is voluntary. That means it cannot contract until you decide for it to contract, which means you have to have this idea in your head that you want to take your hand off the hot stove and get it away. You have to have that idea. So there's going to be this message that's going to be sent to the muscle to give it these instructions. That nerve impulse, we're going to talk about that. That's one of the big things that we're going to talk about in a few days. That nerve impulse, I want you to write in the margin, is going to be called an action potential. And this is where electricity, okay, this is where electricity kind of comes into play. But that is going to be called an action potential. So an action potential, this little idea, this little electrical energy is going to leave your brain, go down through your foramen magnum. That was the big hole in your skull where your spinal cord goes down through your spinal canal and gets to your hand. A nerve is going to branch out and get to your hand and tell those muscles to retract, to contract and retract and get that hand off a hot stove. Okay? So number 1, a nerve impulse is going to be sent to the muscle from the brain in order to tell the muscle to contract. That is going to trigger number 2. Number 2 says that ACH. Now, you will know what ACH is by the end of this chapter. Okay? ACH is short for acetylcholine. Now, acetylcholine, please write this in the margin, is a neurotransmitter. N-E-U-R-O transmitter, a neurotransmitter. That action potential, that idea, that little piece of electricity is going to go down, and when it stimulates that muscle, it's going to release this chemical, and this chemical is acetylcholine. It is a neurotransmitter, and that is going to trigger number 3. Number 3 said a muscle impulse, which triggers number 4. Yes, number 4. I lost count there for a second. The release of calcium from the sarcoplasmic reticulum. What does sarcoplasmic reticulum sound like? Kind of sounds like endoplasmic reticulum, right? Because it is. Sarcoplasmic reticulum is just the endoplasmic reticulum specifically for a muscle. Like sarcolemma was the cell membrane specifically for a muscle cell or muscle fiber. Sarcoplasmic reticulum is just the special name to know that we're talking about muscle for the ER. Okay, now the ER actually, it kind of gathers up calcium. So when it gets this impulse, it is going to trigger the sarcoplasmic reticulum to release calcium. It's going to release its calcium. Number 5, calcium enters the muscle fibers, and this is where we're going to start this situation over here. Calcium enters the muscle fibers and attaches to troponin. Okay, now this is a time that you might want to grab your book, and in my book, it is on page 286. But there is a picture that looks like this. Okay, you see that? Where my hand is on this side. I want you to look at the bottom of that. What this page is doing is it's showing you the parts of actin and myosin. So before we go any further with this, I want you to first know the different parts of actin and myosin. Now starting with actin, it is the thin filament. It is the blue filament on this page. There are a couple things on that thin filament. There's something called tropomyosin. Now tropomyosin, it looks like a cable that is wrapping around actin. And when relaxed, when the muscle fiber is relaxed, tropomyosin is going to block the myosin binding sites for actin. Okay, now in a muscle contraction, they're going to bind together. And we'll talk about that in just a second. But when they're at a relaxed state, tropomyosin that's kind of wrapped around actin is going to block binding sites for the myosin. There's one more thing on actin. There's something called troponin or troponin, just depending on who's saying it. The troponin is going to bind to tropomyosin. Troponin binds tropomyosin to the actin and holds it in place. Okay, so troponin binds the tropomyosin, the cable, and holds it tight to the actin filament. Okay, so that is the part of actin. Now myosin is the thick filament. Myosin has these little heads, and these little heads, they look like golf clubs, like reverse golf clubs. They are going to move and they're going to try to attach to actin. That is kind of what we want to eventually happen. And when they bind to actin, we say that it has formed a cross bridge. Okay, so we're going to back up here and go back to our steps for a second. Go back to our steps, and we were on number 5. So calcium that was released by our sarcoplasmic reticulum, it is going to enter the muscle fiber and attach to the troponin. Okay, it is going to attach to the troponin. This is going to trigger something else to happen. It's going to trigger number 6, tropomyosin, to alter its shape a little bit, and when it alters its shape, it is going to actually uncover the binding site. that is going to allow, once it uncovers that binding site, that is going to allow the myosin head to have a binding site, have somewhere to go. So number 7, myosin cross bridges attach to the actin binding site and pull on the actin filament. Now, this all is going to take energy, right? This doesn't happen on its own. There's a lot of stuff going on here. There's calcium coming down, it's binding to something, it's uncovering something else, and now we've got this little cross bridge. It's got to have some type of energy to make it go. So, number 8, ATP. That is, remember, that's our energy. This is a constant. You're going to hear about ATP for the rest of this semester, and you're going to hear it the rest of next semester. ATP is our energy. Now remember, ATP is constantly being formed. ATP is going to break down into AD, as in dog, ADP, and give off 1-phosphate. Okay, that's what always happens. ATP, when it gets used, it gets broken down into ADP and a phosphate. And then when it's kind of recycled, it turns right back into ATP, and that's more energy. Okay, so number 8, ATP binds to myosin, the myosin cross bridge, which triggers release from actin. And number 9, ATP breaks down to ADP and phosphate, which provides the energy needed for myosin cross bridge to get back into a cocked position, and this happens over and over and over again. Now, this picture is showing you those different steps. Number 1, it says, and every book and every picture is going to explain it or put into words what they found was the most important part of it. So let's see what this one has to say. Number 1, exposed binding sites on actin allow the muscle contraction cycle to occur. And you see calcium there. That means the calcium has come, ADP and a phosphate. And you see the little heads of the myosin, and you see the tropomyosin, the thin filament. Actin is the one on top. You can see the little thin tropomyosin wrapped around it. Okay. Number 2, cross bridges attach. So now the cross bridge, the myosin heads have attached. They've found their spot where they can attach to, and they are attached to actin. Number 3, the cross bridge pulls the actin filament. Now this is called a power stroke. Okay, when they pull, it's a power stroke. ADP and phosphate are released from the myosin. They let it go. Number 4, new ATP binds to myosin, causing linkage to release. And number 5, the ATP splits, which provides the power to cock the myosin back again. So ATP, once it attached, when it breaks and when it breaks down into ADP and a phosphate, that gives that energy to move back again to get ready to attach and then power stroke one more time. This just keeps getting repeated over and over and over again. You need the calcium to be released. The calcium is going to attach to the troponin. That is going to cause tropomyosin to move a little bit. That is going to show the binding sites to the myosin heads. That's going to allow them to attach and form a cross bridge. You have ATP breaking down into ADP and a phosphate to allow this power stroke. And then you need that ATP back again to cock back that myosin head to get ready to do another power stroke. This just keeps getting repeated over and over and over again. Please watch those videos because they're going to explain it in a different way that might make more sense than me. I would always keep a book open, and you can always stop those videos and refer back to your pictures so that you can really see what's going on. Make sure you understand that actin is our thin filament with tropomyosin winding around it and troponin also on it. that myosin is your thick filament. Myosin has these heads that look like kind of like golf clubs that come up, and ATP is needed to cock them back again. We need calcium to move troponin and tropomyosin to allow them to bind, and once bound, it can move that actin forward, and that's how you get the sliding filament. None of these fibers, an actin or myosin, they never actually shrink in length, but you have overlapping. When you look at that sarcomere and you look at the thin and the thick filaments, they slide. That's what shortens the muscle. The individual fibers aren't shortening per se, but they're sliding, and that is what gives you a shortened muscle. So when you have that myosin get onto the actin and be able to power stroke it, that's what brings the actin over the top of the myosin. Okay? Watch the videos for sure. This will help a whole lot.